Good morning, people. So Wednesday, December 1, we continue our classes. So Amarat had questions, so you can post it now or give me a page or any information and we will, let me find some empty slide, probably here. Okay, go ahead. What was the question? Okay, Lakeside Resort offered a midweek package for $199 per night for two people. The package included accommodation in one bedroom suite, which regularly sold for $225, breakfast for two, regularly priced at $12 per person, and 50% discount on a spa treatment at value of $20. What was the markdown? Okay, so let's analyze what we have. So we have midweek package per night for two people. So we have what was marked down at which the package was sold. Okay, give me a moment. Take my glasses. So we have price $199, $199. Okay, that's actually SP, right? Okay, SP 199. Regular S is 225. Okay, regular priced. So we have 12 per person, that's 24, right? Price 12 per person on spa treatment of value $20. Okay, 50 discount percent. What is the markdown which the package was sold? So spa treatment, they don't clearly say what is it, $20 per person or for two. Okay, per person. Okay, so if it is, we have 20 bucks, right? So 20 plus 20, 50%, that's 20. And total we have what? Plus 24 plus 20, 243 for two people, yes or no? So this plus that. Make sense? That's discounted price. The markdown at which package was sold. So normal price, that's SP. Let's put it right, SP. Normal price is 225 plus 24. We don't have any discounts for breakfast, right? Plus 40. Okay, 225 plus 24 plus 40. That is 289. That is S. Looks okay? So what the markdown at which project? So markdown amount, it is 289 minus 243. It's 46 bucks. And markdown rate, it's 46 over 289. At 0.5916955, so approximately 15.92%, something like that. Do you have the answer? Okay, from what you posted, if 20 bucks we have per person, so for 50% discount. Okay, those are steps. So you need to know S and you need to know SP. That's it. Then you can find markdown amount right there, markdown amount, and knowing markdown amount and regular selling price, you can find markdown rate. Okie dokie. So let's, oops, wrong button. So let's start today's class. Chapter 9, compound interest, future value, present value. Okay, we start with formulas. Let's start with formulas. So future value, it is present value, 1 plus I, exponent n. Present value is future value, 1 plus I, exponent negative n. I, it is j over m, right? N, it is tm. So m varies 1, 2, 4, 12, 26, 52, 365. That's it. Those are our formulas for today's class. Any questions? Okay, so let's work. So as we did last time, you have what? Some time. You do it, then I do it. We compare results, ask questions if we have any. Loan of 5,000 with interest 775 compounded semi-annually is repaid after 5 years, 10 months. What is the amount of the interest paid? Okay, people, do it. You have a minute. Okay, so what do we have? To find interest, we need to find future value, right? Future value, what we have, what? Time, 10 months. And we compound semi-annually. So we need to work with t first. 5 plus 10 over 12. So what is that? 10 over 12. That's 5.83 in period. That's years. So then I can calculate n is 5.83 in period times 2. So let me plus 5 times 2. That's 11.6 in period. So let's find I as soon as we hear 75 over 2, 0775 over 2, 003875. Okay, now so we're ready to calculate the future value. 5,000, 1.03875, exponent 11.6 in period. So, okay, times 5,000, 7,791,10. Do you have the same future value, people? So interest is 7,791,10 minus 5,000. It is 2,791,10. That is the answer. Any questions? Okay, can I continue, people? Guys, say something. Okay, thank you. Next, investment of 2,500 earns interest 4.5 compounded monthly for 3 years. At that time, the interest rate is changed to 5% compounded quarterly. How much will the accumulated value be 1.5 years after the change? Okay, so take 2 minutes and do it. Okay, so here I would recommend to make a timeline. So, and we have 2,500, 3 years. So now we change interest rate and we have 4.5 years. That's my time points. Now interest. I have J12, 4.5%. Here I have J4, 5%. So we know that we have to stop and recalculate values on at the point of each transaction. So our first step is to find future value from 25,000. Oops, not 1,000. I mean 100. $2,500. So what is I? Okay, 00375. Now 36. That's exponent. And future value is 2,860.62. So this value is right here at this point. Do you have the same value, guys? people. Okay. Step number 2. Oops. Wrong tool. Step number 2, I take that value I calculated. I change interest rate to 5% compounded quarterly. So 1.5 years, that's exponent 6. Exponent 6 times 28, 60, 68, 30, 82, 05. So this value actually is right there. That is the answer. Any questions, guys? So here, important step, important piece of knowledge, that we stop at the moment of transaction, recalculate everything, then make changes and apply for our next calculations. Terry started an RRSP on March 1, 2016 with a deposit of $2,000. She added $1,800 on December 1, 2018, $1,700 on September 1, 2020. What is the accumulated value on her account on December 1, 2027 if interest is 7.5 compounded quarterly? Okay, guys, take what, 2 minutes, 2 or 3, take 3 and do it. Okay, so again, I would recommend, always forget to change for pen. I recommend to make a timeline. So March 1, 2016, it was $2,000. Then December 1, 2018, 1,800. I put plus, so I know I added to the account September 1, 2020 plus 1,700. So finally, December 1, 2027. So we have interest J4 7.5%, It's steady for entire investment, doesn't change. So basically we need what? 1, 2, 3 steps of our calculations. Let's do step 1. Let me see if I have an extra page. Yes, I do. So let's find I. So 0.75 over 4, 0.01875. Okay, it's 8. So step 1, future value of 2000. Now time. So from March 1 to March 1, I have 2 years, right? So 2 years. Now let's calculate month. April, May, June, July, August, September, October, November, December. 9 months. So I have, let me calculate here, N is 275 times 4. Right, guys? It's 11. So exponent 11. And I have exponent 11 times 2000. So 2, 4, 5, 3, 43. They have the same value, guys. Or you just following me? Honestly, are you following me, or you already have calculated? Okay, T. So, okay. So in a calculator, you mean just how I program calculator, or how I calculate it as just exponent, Jordan? Because seems to me we don't use, you guys don't use Texas Instruments, right? So anyways, let me show you steps, how I did it. I take this, I put button what for gives me exponential function, that's 11, then times, you may press equal here, depends on your calculator. I don't, so I times 2000 equals, that's how I do it. That's what you need, Jordan? Okay, good. So T, from December to December we have 2 years, right? But we need to roll back a little bit. So October, November, 3 months. So 1 year and 9 months. Please confirm my number. Okay. So therefore I need to flip a page. For step 2, N is 175 times 4. So what is that? Times 4, it's 7. And therefore, what was the value there? 245343. 245343. Actually, no. Let's do this way. Let's add deposit here, right? So deposit at that moment. So what we do? 245343 plus 1800. That's what we have to do, right? 43 plus 1800. That's 425343. That's the Value as of December 1. So value as of December 1 after additional deposit of 1800. Okay. Can I flip a page now? Okay, so here number is different because we had a deposit, so 425343, 1.0875 exponent 7. So let me double check the number. Yeah. So exponent 7 times 25343 484409. Actually, if I round, I can make it 10. Let's make it 10. Okay, additional 1700 plus 1700. That's 654410. Okay, guys, so far, any questions? Okay. Now let's work with the last step. Last step, what is that? T. September to December. So I have 7 years and October, November, December, 3 months, right? 7 years, 3 months. So step 3, N is 725 times 4. It should be 29, right? It is 29. So 654410, 1.01875 exponent 29. 1121.530. That is the final answer. That is the final answer. Let me know when you're ready to continue. Ready. Okay, Sheridan Service has a line of credit loan with the bank. The initial loan balance was 6,000. Payments of 2,000 and 3,000 were made after 4 months and 9 months respectively. At the end of the year, Sheridan Service borrowed an additional 4,000. 6 months later, the line of credit loan was converted into collateral mortgage loan. That was the amount of the mortgage loan if the line of credit interest was 9% compounded monthly. So, would you like to try it, or you want me to start it now so we don't lose time? Guys, now. Okay, now let's make a timeline. So initial loan, let's put it now, $6,000. Then 4 months, I put minus 2,000. Just I paid the loan, right? That's all subjective, but as soon as you understand what your marks are, as soon as you remember what is the process happening, The plus or minus honestly make no difference. So at the end of 1 year, so point the refed mark 1 year. So we put plus 4,000. So we took another loan, right? Then 6 months later, it means 1.5 years, we convert it into collateral mortgage. What amount of the mortgage? Now, interest rate, to tell you what short words, mortgage assumes regular payments. It could be monthly payments or quarterly payments, no, mostly monthly payments or bi-weekly payments. But most of the time, payments are monthly. So this this process called annuity, and that is behind the scope of that course. If you take next math course, you will learn annuities. You will learn annuities. So for now, mortgage, what I have, J12, 9%. And let's calculate. So first step, 6,000, 1.0075, 4 months. I compound monthly, right? So exponent is 4. Let me calculate it. Times 6,000. I have this 18204. Now what happened? I paid $2,000. Okay. Step 2. We continue. It's like declining balance method. We do step by step as time flows. So here I have what, 5 months, right? By all means, guys, if you have any questions, please ask. So 43, 41, and please calculate with me. 37. And I pay 3,000. Okay. Then step number 3. Step number 3. What I have, 10, 11, 3 months, right? So 1, 3, 4, 1, 37. 3 months. That's 3. So 1, 3, 7, 1, 78. Is it? Let me double check. Yeah. And at that moment, I take additional loan. So add 4,000. 5, 3, 7, 1, 78. So far, people using just the time and not for the exponent. Well, it is at this time. Time and exponent are same thing. Let me show you. For step 1, what we had, 4 months, right? Jordan. So N1, it is 4 months, which is 4 over 12 times 12 because you compound monthly, yes? Yes. So for each next step, I have 5 months here, right? So 5 over 12 times 12, it is 5. So another way of thinking, I compound monthly. It means as many months I have, as many compound periods I have. Make sense? Okay, good. Any other questions, guys? So we at the point of 1 year. Then they got tired from all these games and say, okay, let's pay mortgage. Actually, year and a half. So 5-3, or something changed in their financial stuff. They don't have ability to put chunks of money. Any reason, we don't know the reason, right? So 6 months, right? Half a year, 6 months. 5618009. That is amount of the mortgage loan. Ask me questions if any. And let me know when we're good to go. Okay. Variable rate demand loans showed an initial balance of 12,000, payments of 5 after 18, 4 after 30 months, and the final payment 5 years. Interest was 11 compounded semi-annually for the first 2 years and 12 compounded monthly for the remaining time. What is the size of the final payment? So I assume that we start now, right? You don't want to do it. So now, 12,000, 12 grand, 18 months minus 5,000, 30 months minus 4,000, 5 years, balance. I put balance here. Okay, now payments are done. What about interest? First 2 years, so J2 is 11%. The first 2 years is 24 months, is somewhere here. 2 years, so I have J12 is 12%. That's it. We didn't change anything after that. Any questions so far, guys? Does everyone understand what is happening? So we have this interval. Now I'm highlighting intervals in between transactions. This interval. Then I have this interval. And finally, that interval. So we need to stop at each moment, recalculate values. So let's do it. So 12,000, 11% semi-annual. That's 1.055. Now 18-month exponent, that's what, 3. Does everyone understand exponent or you need explanation? Understand, very good. So 14 90. At that brave moment, we pay $5,000. We have $9,090.90. Wow, beautiful number, huh? 90, 90, 90. Okay, step number next. That beautiful number. We carry on with the same interest rate for the next 24 minus 18, 6 months. 6 months we compound semi-annually, so exponent is 1. So 99.90 times 1.055. So 959090. So does everyone understand that step, guys? Okay, very good. Step number next, we change interest rate, right? For what? 30 minus 24, that's 6 months. So 959090. 1.01 exponent 6. Okay, $10,180.93. At that happy moment, we pay $4,000, and we have 6,000 and a little more as outstanding balance. And finally, so 5 times 12 is 60 minus 30, that is 30. So here, 30 months, right? So 6 months, 18093. Interest rate 12% monthly, so exponent 30. Oops. So 833096. That's how much has to be paid at the point of 5 years. So confirm my calculations, guys. Let me know when you're ready to continue. Okay. A variable rate demand loan showed an initial balance of 9,000, payments of 2,500 after 6 months, 2,500 after 21 months, and final payment after 4 years. Interest was 8% compounded quarterly for the first 21st month and 7.75 compounded monthly for the remaining time. What was the size of the final payment? You guys want to do it? People. Sure, let's take what? Take 3 minutes. At least you will start something. Okay, so let's see what we have. So 9,000 balance. That's the start of the game. 6 months. And guys, we have to clearly understand what is happening. So we paying the loan or we accumulating money. That's important to understand at the very beginning. Here we paying the loan, right? 21 months, 2,500. Okay, final payment 4 years. Okay, interest. Let me put this way. I highlight it. And actually, do I need to highlight it? Probably not. Let's erase it. Let's highlight. So I just put J4 is 8%. And then at this point, I put J12, 7.75%. That's it. What I will highlight my steps. This one, that one, and that one. So let's do it. So first step, 9,000, 1.02. So 6 months quarterly, that's exponent 2. So 9, 3, 6, 3, 60. Then I have payment of 2,500. So balance will be 686360. First step is done. So next 686360. Same interest rate. Now here, what is it? 21 minus 6 is 15 months, and it is 5 quarters. Yes, guys. So 7, 5, 7, 7, 97. And I have payment again. So I have 5, 0, 7, 7, 97. So guys, are you following me so far? Any questions? Okay, so last step, 507797. Interest rate was changed. Let me calculate I. I is nice, beautiful, long number. 64583 in period. Let me memorize it so I don't have to. Now time here. So 4 times 12 is 48 minus 21. We have 27 months. I compound monthly, so exponent is 27. So 604195. That's the final answer. I offered to take a break. So let's have a break for 10 minutes. All right, so what do we have? Be back at 9:03. A little more than 10 minutes. So guys, break. Okay, guys, break is over. Let's continue. Okay, so goodness, sorry. What sum of money will grow to 2,000 in 7 years at 9% compounded monthly? I think you can do it. Guys, first, before we do anything, say I, so I know you came back. Okay, you came back. Very good. So, I think you can do it. Go ahead, 1 minute. Okay, I think there's enough time. So this time we're looking for present value. Just to refresh formulas, that's the one. So present value, actually it's PV. So 2000, 1.0075, 7 years, monthly it's 80 something, right? 84. Okay, that's your equation. $1,067.69. That's the answer. Do you have the same value? Okay. Determine the sum of money that accumulates to 1,600 at 5 compounded quarterly in 6 years, 4 months. Okay, do it. 1 minute. Okay. So again, present value. First, let's work with time. Okay. So time is not very convenient here. We have 6 years plus 4 over 12 years. So what is that? 6.3 in period years. N is 6.3 in period times 4. And it is 25 and 3 in period. Therefore, present value, it is 1,600, 1.0 0.125, negative 25, and 3 in period. So let's do it. We have 1168. That's it. Maybe a 1. Confirm my value, please. People, do you have the same answer? Okay, let's move forward. In negotiating a contract for your business, you have to decide between receiving 50K now or 20K now and 35K 3 years from now. In terms of today dollar, which choice is better and by how much? Money is worth for 25 compounded annual. Okay, you want to try it or you want me to do it right away? People, what's your choice? Try. Okay. Take 2 minutes. Do it. Okay. So we have two options. We have two options. Option one. Option one. Let me put this way. Now, 50,000. Option two. I have 20,000 now, and 3 years I have 35,000. So what I have J1 for 25%. Right? With option one, everything clear. It's 50K today, and that's it, right? Regarding option 2, we need to take 35,000 and bring it back to the point of decision making, which is right here to now. So 20,000 plus, let me calculate, $30,891.56, 5891.56. So which option is better? So I have 50,000. Oops, it was bad decision. 50,000. Or I have decimal. Which option is better, people? The second one. Yes, of course we don't consider inflation here. But if even inflation 2.7% a year, right? So we still have some money anyways. Okay. Next. Harpreet's parents deposited a lump sum of money into savings account for him on his 10th birthday at an interest rate of 5% compounded semi-annually. 3 years later, they opened a new account for him. They deposited 5,000 to his new account and transferred over the balance from the original account. The new account paid interest $4.95 compounded daily. How much money was originally invested if Harpreet had 15,067 cents at the account on the day he turned 19? Okay, you want to try it, people, or you want me to do it? Guys, your decision. Okay. Somebody say try it, somebody say together. Okay, let's do it this way. I give you 2 minutes and you still try it, and then I will start. Okay, 2 minutes. Okay, let's do it. Let's do it. I think we can use one-time line. So they deposited the amount of money. Let's put it X. Okay, 3 years later, now 3 years later, that's fairy tale story about what? New account, blah, blah, blah. So basically they add 5,000 to whatever was accumulated, right? It's not now actually. Let's use his what age? On him 10th birthday, right? So he was 10 years, 13 years, 19 years. The moment of 19 years, he has 15K. Okay, that's it. Now let's mark interest. So here it was J2, 5%. His sort of new account is J365. Oh, that's nice account. 495%. Okay. So this time we need to roll back. So step 1, we roll back 15,067 cents. Let me find I 000135616. So we memorize it. And then 19 minus 13, what I have, 6 years, right, times 365, it's negative 2,190. So far, guys, do you understand all the numbers what I just put on the board? Okay. So let's calculate. So 11, 146, 38. Now, this amount is right there. So question is, what we do with 5,000? We subtract from that amount or we add to that amount? Subtract. Very good. Very good. Very, very good. So minus $5,000. What is that? $6,146.38. Do I have another page? Yes or no? Yes. Okay, so, and we roll back again. 6,146.38. Now interest rate was different. It was J2 5%, 0.25. And how long it was it? For 3 years, semi-annually, minus 6. Okay. Times 6,146.38. $5,300. That's amount what was deposited originally for that kid. Questions, people? So the main thing, the main step here is to understand the process. What is actually happening? Right? So if you understand what is happening, that's already half of the job done. Okay, scheduled payments of 6, 8, and 1200 are due in 1 year, 3 years, and 6 years, respectively. What is the equivalent single payment 2.5 years from now if interest 7.5 compounded monthly? 1 minute, 2 minutes. Do it. Do it, guys. Okay, so timeline. Now, 1 year, 600, 3 years, 800, and 6 years, 1200. Single payment, 2.5 years, somewhere here, X. And I have J12, 7.5%. What is the focal date? Do we need actually focal date here? Yes, guys, or no? Do we need a focal date? People. Yes, we do, of course. So I offer is here. Yeah. So what do we have? We have X equals 600. So future value, right? Let me calculate I. So 1.5 years monthly. Let me memorize it. Hold on a second. Monthly, that's 18. Oops, no equal. That's too soon for equal. Plus 800. Same interest rate, of course. And I have what, half a year minus 6 plus 1200, same interest. So 6 minus 2.5, that's 3.5 years times 12 minus 42. So please have a look on this equation and let me know if you have any questions. So no questions, that's good. $65 plus so X is 2,365.57. Questions, guys? Okay, I have question. Was it good decision to pay the single payment or bad decision? What do you say? Three possible answers. Good, bad, I don't know. Good. Good decision. And next question, why it was good decision? Yes. The answer is right because he paid less at the end of the game. Very good, guys. Very good. Question number next. Scheduled payment of 12,100 due 1 year ago, 1,006 months ago, to be repaid by payment 800 now, and second payment of 1,000 9 months from now, and final payment 18 months from now. What is the size of final payment if interest 10.8% compounded quarterly? Okay, take 3 minutes, do it. Okay, let's do it. Let's do it. Timeline 1 year, 1200. 6 months, 1000. Now, then instead of that music, we will have a new one. 800, 9 months, it should be 9,000, and 18 months, X. Guys, focal date, any suggestions? 18 months, okay, let's do both, right? Let's see what happened. 18 months was first suggestion, so let's first do 18 months. So agreement 1. A1, 1200. I, let me find interest rate. 108 divided on 4. Memorize. Hold on. Something happened with my calculator. Okay. 0.27 and 18 months, right? So here I have 12, 12 plus 18, 30 months, right? 30 months quarterly, it's 10 plus 1000, 27. So what I have, 18 plus 6, 24, that's 8. Any questions regarding exponents, guys? Okay, if you have any, please ask. I will explain. $55. So A1 plus 1237.55, that's $2,803.89. A2, okay, 800. So 18 months, that's exponent 6 plus 1000. 9 months, exponent 3 plus x. 938, 67 plus 1083, 21 plus x. So A2 it is. That's 2021.88 plus x. Okay, to save space, I make it equal to 2803.89. That is my equation, and x will be $782.01. Okay, any questions? That was focal date 18 months. Now let's do this. Focal date 18 month. Now second option, let's make it now. Next page, focal date now. So agreement 1. Agreement 1. 1200 year ago. 1200. Let me see. 10. Everything's fine. So exponent 4 plus 1006 months ago. Exponent 2. 1334 94 plus 1054 73. So agreement 1 plus 2389 67. Agreement 2. $800 is already there, so we use it as is. Y minus 4. 800 is in the focal date. We don't move it. If focal date now, 800 is in focal date, so we use it as is. $1,000, y minus 4. You move it what? To the future. Yes? So we use future value formula. Okay. So 1,000, 9 months. $1,000. 9 months is minus 3 plus x. It was 18 months, right, guys? Yes or no? Yes, so 6 minus 6. So agreement 2, 800 plus times 1,000, 923, 18 plus 0.85 227 0269 times x. So A2 it is $1,723.18 plus this value for x. I mean this term. So, and again, I'd be lazy, saving time. 2389.67. That's the equation. So let's okay. X is 782 or 102. What did we have? Well, 1 cent different. So basically same thing. And again, theoretically, different focal date gives different answers. We have discrepancy 1 cent here. Probably we have small values and small time intervals. So they are basically Same. Questions? So finish your calculations. Let's see how many more I have. Oh, I have a lot of questions still. Okay. But you know, these techniques we already did with simple interest. Let's quickly do them and say goodbye for today. Loan of 3,000 borrowed today is to be repaid in 3 equal installments due in 1 year, 3 years, and 5 years, respectively. What is the size of equal installments if money is worth this much? So now 3,000, and I have 1 year X, 3 years X, and 5 years X. So what I do, focal date is now, right, guys? Focal date is now, and I take everything to focal date. So 3,000 is already there. Let me calculate. So minus 12 plus X minus 36 plus X minus 60. So have a look on that equation. Let me know if you don't understand, for example, exponents. Okay, so 12 negative 1. Again, I use calculator's memory to memorize those numbers. So serves two purposes. Purpose number 1, I don't have to put it back in calculator by hand. Purpose number 2, reduces risk of mistake. Because when I put back manually, I can what? Put wrong number, etc., etc. And it takes time. $84 2722 X. So 3,000 equals. Now I add them up. 2 5 4 1 3 8 3 9 times X. X is $1,231.82. So let me know when we're good to go. Okay. What is the size of equal payments that must be made at the end of each of the next 4 years to settle a debt of 3,000 4 years from now and subject to interest 10% compounded annually? So now 4 years, 3,000 sits right there. Okay. End of each of the next 4 years. So let me use different color. 1 year, 2 years, 3 years, and 4 years. So X, 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 X. Focal date is wise to do on 4 years. So 3,000, it's already in the focal date. equals to x annually, 1.1 exponent 123 plus x, that's 2 years, that's 3 years, 1.1 exponent 2 plus x, 1.1 exponent 1 and plus x. So have a look at that equation. Ask me questions if you don't understand something. So $3,000. Let me add this together. Here I remember that last term has coefficient 1, right? Guys, multiplier 1 in front. Okay, so let me know when you're done. Well, the reason for that is following. I do not move 3,000, right? I keep it as is. I do not move X, last payment, I keep it as is. The only 3 values I move, that's 3 unknown payments. Right? If I choose focal date now, I have to move 1, 2, 3, 4 unknown payments and 3,000. Everything to focal date now. And again, focal date, that's subject for negotiation. Right? Subject for negotiation. So was it a good decision to pay these 4 payments? Yes or no? People. What do you say? Yes, yeah, so logic is the same. So we calculate total payment and it's less than 3,000, so we save some money. Okay, so that's the last question, I believe, right? So here we had question. So scheduled payments 8,800 due 2 years ago and 1,000 due in 5 years are to be repaid by 2 equal payments. The first replacement payment is due in 4 years and second in 8 years. Determine the size of the 2 replacement payments. If interest 12% compound is semi-annual and the focal date is 4 years from now. Now they're telling us when they want to have a focal date. So let's see. 2 years ago, 2 years, 800. Now, and I have 5 years, 1,000. So that was original agreement. Instead, 2 equal payments. The first 4 years, and the second 8 years. Right? Okay. Focal date they want here. So let's do it. Let's have agreement by agreement. A1. Do I have extra page? Yes, I do. Yes, I need it. So 800 12 compounded semi-annually. So what is that? 1.06. Now, what I have, 6 years, right? That's 12 plus $1,000, 1.06 minus 2, right, guys? Times 800, so 0976 plus 889, basically 890. That's, it can be rounded to. So A1 is 1609.76 plus 890, 2499.76. So that is agreement 1. Agreement 2, I have X is already in the focal date. Second one, I need to bring it back in time for 4 years, semi-annually, so minus 8. So 1, 6, I already I calculated that term, and plus I added 1. So that's the final answer for agreement 1. Again, being lazy, I make it equal to 499.76. That is my equation. One 53603. That's the answer. So this time it was what? It was bad decision, right? It was very bad decision. Okay, let me know when you're done. Okay, very good. So we did chapter 9 today. That's exercise for review. Our next class we will do chapter 10, and then rest we will prepare. We'll do preparation for the test. So please do this homework. What I ask, review this review exercises after each chapter. Have your questions. Seems to me I posted all the quizzes already online, so you can find them. Maybe the last one I didn't. I will check. I will have a look. So that's it. Thank you for class, and see you next week. Bye bye.